concurrency control. This is the concurrency control. Concurrency control is basically of three types. The first one is the pessimistic concurrency control. The second one is the optimistic. And the third one is the semi-optimistic. Semi-optimistic. So these are the three types of concurrency control we are having: pessimistic, optimistic, and semi-optimistic. Three types of control, three types of concurrency control we are having. Okay, what's the meaning of this? What is the meaning of pessimistic? What is the meaning of optimistic? Okay. Pessimistic, in Hindi we call it nirasavadi, means there is no hope. There is no hope. Optimistic, there is hope, ashavadi. And the semi optimistic means ardha asavas, half hopeful, ardha asa, say half hopeful. Here, what is the meaning of hope? In what term they are talking about hope? Hope means they are assuming, they are hopeful, they are, they are assuming that lot of luck are going to happen. Means they are very negative about the luck. Means at the same time, multiple users are requesting for locks. Okay. At the same time, multiple users are requesting for locks. So they are very negative, they are very negative. They are thinking that many people are going to, request the lock at the same time. Okay. Here, they are hopeful, they are optimistic that there is a rare lock going to happen. There is a rare lock going to happen. Lock will be removed shortly. They are also hopeful that lock will be there. Maybe this point don't write. There is a rare lock going to happen. This is, they are thinking that really the lock is going to happen. Means less number of users are trying to access the records. They are optimistic. They are optimistic that there are rare lock going to happen. And this is when possible, when the less number of users are trying to access the records. All right. This semi-optimistic means you can just simply combine together. So this is combination of pessimistic and optimistic. Okay, this is the combination of pessimistic and optimistic. So based upon the requirement actually, but in OData, so whatever you have learned in OData at this point of time, can you tell me which kind of concurrency control we are doing? We were doing the optimistic, or where we were doing the pessimistic, or where we were doing the semi-optimistic. So semi-optimistic is not here in the picture. Now we are keeping a straightforward, either pessimistic or optimistic. So you'll have to select either we are using the pessimistic or we are using the optimistic. What do you think? Which kind of you know. So if you think pessimistic, write 1, or if you think optimistic, write 2 over here in the chat box. Okay. So there is no right or wrong answer, just for the purpose of having the interactiveness. I'm asking whatever you think, which kind of lock we are performing over here. It is the pessimistic or this is the optimistic. So feel free to write over here. I'm waiting for your response. Are you not able to decide, or you are not there? Okay, if you are there, then you are not able to decide. Fine, no issue. Let me go and explain a little more about this, this pessimistic and optimistic, so that you will be able to decide what kind of locking mechanism we are using. Okay, so see, in this optimistic, first let me explain about this pessimistic. Okay, go to the next slides. And pessimistic, so in the pessimistic, that lot of locks are going to trigger by the means lot of requests are going to get triggered by different users. Okay, means there are very much probability of having the locking chances. Okay, so in this kind of situation, right, in this kind of situation, what we generally do, we lock the record itself. We lock the record, right? So in the pessimistic concurrency control, we lock the record itself. We lock the record itself. See here, we are having this particular record. Okay, copy this and paste it here. We lock the entire record in the pessimistic, because we know that lock the entire record. So when you lock the entire record, all the access control, all the access file to this record will be discarded. So one example of pessimistic concurrency control is, see here, LV underscore calculation hash method. I have opened it over here. If I am going to another session slash OAC 24, sorry, I will take some another example, maybe slash n AC 11 Z PO header. This is one. Go into the change mode, right? So you are here in the change mode. Again, if you are going to AC 11, then ZPO header, you will not be able to open into a new task will be created. Okay, that is fine. You can see that user is currently editing. What it is doing, what we are doing, we are locking the table itself. We are locking the table directly itself, right? That means similarly, if you have some in SM30, if you have some table, right? So in SM30, we'll be having some table and you are editing some record over there, then it will not allow, if you're editing this table, it will not allow you to open in the another session, and it will not allow you to, edit this one, right? So this kind of lock where record itself you are locking, right? That is known as the pessimistic. Okay, so you are having the read lock, write lock. Read lock is nothing but the shared lock, write lock exclusive, and cumulative exclusive but not cumulative, right? The different kinds of lock you are having under the pessimistic concurrency control. Under the optimistic currency control, what happens? The one which we have discussed in this O data, we are not locking the record. If you observe over here, if you see here, are we locking the record? No, we are not locking the record. Just we are setting a mechanism. Just we are setting some mechanism through which it will identify if the record has been changed, right? So for the purpose of achieving the for the purpose of avoiding the data inconsistency, either you can use the pessimistic control, pessimistic concurrency control, where record itself you are going to lock, so no other people, there is no chance for any other people to go and disturb that. Okay, but it is having some problem. You will have to wait until your transaction is going to complete, right? You will have to wait. Other user has to wait until you are going to complete all your do things and click on the save button and come out from the transaction, right? Or if, for example, if you have slash and mm02, right? So if you are here, you are having some material number. So if you are editing some material number, other people has to wait for to edit the 393, you know, uh, uh, material number to wait. Once you complete this editing, then only he will be able to, you know, come back and do the stuff. So under the pessimistic, you will have to wait. You will have to wait till your transaction is complete. Okay, till your transaction to complete. But here, you know, here no nothing, no need of wait. Node a need to wait till the transaction is completed, right? You don't have to wait that much time, you know. There is no wait at all, no wait at all, you know, no wait at all, no need to wait till the transaction, no wait at all, right? Are you able to understand this concept? No wait at all, right? No wait at all. Very good. So you understood this concept, you know, the pessimistic and optimistic. In optimistic, so but like, you know, if you have large number of user, maybe this pessimistic is going to help you, know, and this may be more better thing to do, because in optimistic, until and unless you are going to perform the right, in pessimistic, until and unless you are going to perform the update, you will not come to know that if your data is inconsistent, right? You have seen here, you have seen here in SCGW and under the gateway client, we are not able to find if my data is changed or how. Like once we fire the put operation, the update operation, that means the write operation, then only we are going to come to know, okay, we have to change, right? So this is one drawback with this. There you will come to know in beginning itself, right? So whenever you are going to change any record, if already log are there, it will tell that some other person is editing, please wait, right? But it it consumes lot of resource. It consumes lot of resource because it put the lock. It consumes lot of resource, and from performance, not good. From performance point of view, from performance point of view, not good, because lock is going to be there, you know. And when you have to lock something, means your resource and everything is busy to do the locking, right? Here it is not the case, right? Here it is not the case, because you are not locking, your resources are free, right? Because you are not locking, your resources are free. But the problem is that, uh, until you perform the update or write, or read. Indeed, also, like you have seen that, when I'm using the read, if something is changed, right? If something is changed, it is asking me to pass that entity tag, right? So until you perform the update or write, or write means the insert, creating of new record. Update means just you are updating. Okay. So write will involve update and insert both. Okay. Update, write, or read operation, until you perform the update or read operation, will not come to know. You will not come to know about data inconsistency or someone has changed the data, right? Here in beginning itself you will come to know. Okay. So suppose if you have changed a lot of data at UI side and you are clicking on the submit button, then only will uh, so at the UI side you will have to handle, right? At the UI side you will have to handle, so that you will click on the submit button, your all data should not disappear, otherwise again you will have to fill the data, right? So that is the thing, right? Hope it's clear. Let's stop our session here. If you have any question, just ask any question if you have.
So, Pankaj, most of the cases it will be pessimistic lock only, right? Depending upon the the clients we are working. Optimistic lock will be very rare, right?
So in O data, we are having the optimistic concurrency control, right? In O data, but in backend, whatever you are doing, all these are the pessimistic only. Okay.
Okay,
In backend, yeah, in backend directly, what you are doing is at the record level itself, you are performing the lock, right? Here in the O data, you are not performing any kind of lock, just you are trying to identify if someone has already changed the record, right?
yeah, depending upon the E tag, right? We are doing the optimistic.
Yes, yeah, depending upon the E tag, you are not locking any
Yes,
record, correct?
yes, yes.
Yeah, here in pessimistic concurrency control, you are locking the record itself, so there is no chance,
Okay. So that pessimistic lock comes under the BAPI update that we're doing, right?
Right.
And that is internally taken care.
Sorry.
The BAPI update, it's taken care internally.
Yes, yeah, that will be taken care by the system itself. This pessimistic one, we also apply the pessimistic one by creating the lock object, right? We go to SE11. Suppose if you are creating some custom program, okay, then we can create the lock object, and when you are going to activate this lock object, there are two function modules which gets generated. One is enqueue and another is dequeue. Using the enqueue, you can lock a particular record. Okay.
Yes,
Yeah. So pessimistic you can achieve using the lock object programmatically, right? And their entry you can see in SM12. Okay.
yes,
In SM12. So for the pessimistic lock in SAP context, SM12 is the T code where you can go and check. In optimistic, there is no T code where you can go and check optimistic, all these things,